Today we're working on section 10.6. This is actually the last section in chapter 10. And chapter 10 is the last chapter of the school year. So this is your last day of notes. Doesn't that feel good? All right, we've got some important things coming up. We're reviewing the next class. Next time I see you, we will start a review. We're going to do a notebook quiz the following day. Thursday we'll review again, and then Friday is your test over chapter 10. We usually stop halfway through a chapter and review. We didn't get a chance to do that this time because we're running out of time. I want to make sure we have a full week to review for exams. So we'll need to spend a little extra time reviewing this week is what that means. So anyway, back to today. Today's all about probability. So our goal is to find the probability that an event will occur. So I am going to give you an event, like what is the probability of flipping a coin and getting a head? And you are going to find that probability. You're probably saying, well, what is probability? Probability is a ratio that shows how likely something is to happen. So keyword ratio. Ratio is a comparison of two numbers. So we're comparing the likelihood that it will happen to how many possible ways it could happen. Okay, so the probability of an event, it could be written like this. You might see this notation in the future, P, and then whatever the event is in parentheses. So the coin toss. It would say P, and then in parentheses it would say heads, because we're talking about the probability of a heads. All right? So when you're finding probability, the number of possible successes is on top. And on the bottom, it's the number of possible outcomes. So back to that landing on heads. If you flip a coin, how many possible ways can it land? Two. There's two possible ways it can land, right? You can get a heads or you can get a tails. So the total number of possible outcomes is 2. If I want to know how likely I am to get a heads, how many ways can you land on heads? Just 1, right? So the number of possible successes being heads, would be 1. The number of possible outcomes would be 2, because you get a heads or a tails. So successes goes on top, total possibilities goes on the bottom. And that's how we find probability. All right, so using the candy box on your notes, so you have to be following along with your own notes because they're not up on the projector. Using that candy box, we're going to answer these questions. So number 1 says, how many total pieces of candy are in the box? 12. So that's not really a probability, but that's going to help us on the next couple. All right, number 2 says, what's the probability of selecting a cherry piece?
3.
So there's 3 possible cherry pieces. So a success in this case would be considered a cherry. There's 3 different ways to pick out cherry, right? There's 12 total candies you could choose from. So the number of successes would be 3. There's 3 cherries. Cherries are successes right now. There's 12 total possible outcomes. Now, if you can reduce in probability, you need to reduce. What is 3 over 12 reduced to? 1 over 4. Very good. Number 3, what's the probability of selecting a lemon piece? So how many lemons are there?
5.
5 possible lemons. Lemon would be success. So 5 lemons. How many total?
12.
12. Does 5 over 12 reduce? It does not. So there you go. And the last one, what's the probability of selecting a grape? So now grape is a success. There are 4 grapes. There are still 12 total. What's 4 over 12 reduced to? 1 over 3. Good. I'm going to ask you a few follow-up questions. Which flavor are you most likely to pick? Lemon. Lemon has the highest probability. Sometimes when you do the reducing and they all have different denominators, it's easier if you change them into decimals, the same way we did when we were doing percents. So you can change them to decimals with fractions. Some people like looking at probability as a decimal. You can do that too. Just do 5 divided by 12 in your calculator. When you're comparing, some people prefer that method. If you go back to the original picture or problem, you can usually figure it out though. Which one is the least likely? Cherry, yes, there's the least number of cherries. Good. What if I ask you for the probability of not cherry? That's a popular question. Like, what's the probability that you will not pick cherry? 9 out of 12. How'd you get that?
Add 4 and 5.
Yeah, you can add 4 and 5, right? These are all the ones that are not cherry. Another way to do it is using subtraction. Like if 3 of them are cherry, and there's 12 total, 12 minus 3 leaves you 9 that are not cherry. So there's a lot of different ways to ask these same types of questions. Those are just a couple of ways. Any questions so far on the front page of your notes? All right, so on the back we're working with this spinner. You guys have played board games with a spinner, right? You like flick it. Sometimes there's like a little knob, you turn it, right? So it spins randomly, you don't know where it's going to stop, all right? So we're going to talk about some probabilities here. What is the probability of landing on a red? So now red is considered a success. There's a red. What's down here though? Yeah, there's 2 possible ways to get red. How many possibilities are there?
4.
4. And 2 over 4 reduces to what?
1 over 2.
1 over 2. So the probability of spinning a red is 1 over 2. All right, number 6. What's the probability of the spinner landing on orange? Yeah, here's orange. There's only one way to get an orange, and there's still 4 possible ways this spinner could land. All right, number 7 is a little tricky. You need a little prior knowledge. What is the probability of the spinner landing on a primary color? What are the primary colors? Red.
Blue.
There's one more.
Yellow.
Yellow. Very good. Orange is not a primary color. These are the 3 primary colors. So, any of those on the spinner?
Red and blue.
There's a red, there's a blue, there's another red. There's no yellow, but we still have to look for it, you know. We have to consider it as an option.
Orange and, no. Didn't you make...
You make orange with red and yellow.
Didn't you make yellow?
You can't make yellow. That's why yellow's a primary. Yes, okay. So orange, you have to put 2 primary colors together, therefore it's no longer primary, right? Little art lesson for you. So how many possible primary colors could we get? How many spaces on the spinner have a primary color? 3 of them. How many total spaces are there? 4. Very good. All right, the next one's more of like a discussion. Mike said you have a 50-50 chance of spinning red. What does that mean? 1/2. How does 50 have to do with, what does 50 have to do with 1/2?
50% is a half.
50% is a half. Very good. So if you think of the probability of red as a percent, it would be 50%. So the way we could explain this is there is a 50% chance of what? Of spinning red. But he says 50 twice. So there's a 50% chance of spinning red and a 50% chance of Not spinning red. Good. So remember when we were going back and forth between decimals and fractions and percents?
Mm-hmm.
You can do that same thing with probability. If you said, technically probability should be the fraction, but you can write it as the decimal, and you can write it as the percent too. But in this class, stick with fractions so that they're all the same.
So we're doing more writing out than problems today?
No, I don't think there's any like number 8 on your homework. It's just nice to get a little discussion going, right?
So we don't know?
You do have homework. I just don't think there's any like short answer types like number 8 on there. All right, 2 more. Are you ready? Next, we are rolling a die. So dice means 2 or more, right? The singular of dice is die. So we're rolling a die, right? You shake it up and you throw it out there. What's the probability that you're going to roll a 1? So how many sides on the dice have a 1 on them? 1. How many total sides are there? 6, right? Each number has a side. So the probability of rolling a 1 is 1 out of 6. I'm going to list the possibilities over here for this next one. You get a 1, you can get a 2, you can get a 3, you can get a 4, you can get a 5, or you can get a 6. What's the probability of rolling a number greater than or equal to 4?
3.
So what would be considered a success? Which one of these numbers over here? 4, 5, and 6. So how many successes are there?
30.
And how many total sides of this die are there? 6. So 1/2. Again, technically you could write this. I'll show you sort of the more advanced way to write this. You'd put P for probability, and then you'd put 4 or greater. And then you could put equals 0.5. That's how most of the problems will look when you get a little farther into probability in your upper level math classes. But for this class, we're just going to stick with this notation. Just write it as a fraction and simplify. Questions?